Alright, proportions, day 1. On your packet, if you find your EP4 Explorer, there is a picture of a bunch of suns and moons. I'm going to show it here. Okay. Oh, there it is, sorry. There they are. First, let's find out how many suns there are. There are 1, 2, 3, 4, 5, 6, 7, 8 suns, and 1, 2, 3, 4, 5, 6 moons. We need that because it says, what is the ratio of moons to suns? Well, we had 6 moons, so you write 6, and we had 8 suns, so we write 8, and then you can use a colon like this. That's how you can write a ratio. Another way to write that same ratio is 6 divided by 8. Those mean the same thing. Now we find the ratio of suns to moons. Well, there were 8 suns and 6 moons. So the ratio is 8 to 6, or 8 divided by 6. See, these are not the same because one is moon to suns and the other is suns to moons. So you have to make sure you put the numbers in the right places. Find the ratio of moons to total objects. Well, there were 6 moons, and in total there are 14 objects. So 6 to 14 is our ratio. Find the ratio of suns to total objects. Well, there were 8 suns and 14 total objects. One of the things you should always be prepared to do is also to simplify your ratios. 6 over 14 is not simplified because I can divide 6 and 14 by 2. So we need to simplify by dividing by 2 on top and bottom, and that gets us 3/7. We should also simplify 8/14. They're both divisible by 2, and so our new ratio is 4/7. Okay. Suppose you want 12 moons drawn in the box. Well, we don't have 12 moons drawn in the box yet, but you want to keep the ratio of the moons to the suns the same. How many suns would you also need to add to that box? Well, okay, right now there are 6 moons, and we want to make 12 moons. Well, that's exactly double, or times 2, the amount that we have. In order to keep the ratio 6 over 8, we have to also multiply 8 times 2, which means we would need a total of 16 suns. So how many suns would we have to draw? We would have to draw 8 suns in order to keep our ratio the same. Alright, so a ratio is a comparison of two quantities by division. And a proportion is a statement that two ratios are equal. So when I did this last step here, when I said that 6/14 was equal to 3/7, that is a proportion. That is two ratios that are actually equal to each other. Alright. So, Johnny is having a party at Pizzaland. He wants the ratio of boys to girls to boys, to be 4:3, and the fire code will only allow 21 kids to attend. That's 21 total kids. How many girls can Johnny invite? So, it says if the ratio of girls to boys is 4:3, how many total people are represented in this ratio? Well, if we had only 4 girls and only 3 boys, it would be 7 total people. So now we're going to write a ratio comparing the number of girls to the total people from part A. Well, okay, girls to boys, girls must be the first number, so that's 4 out of the total number of people we would have, which is 7. Then write a proportion where X represents the number of girls that Johnny can invite. Well, Johnny can invite X girls out of a total of 21 that the fire code will allow him to have. Well, a proportion, though, has to be equal to something. So this is girls, and this is total. This is girls, and this is total. So they can be set equal to each other. I want X out of 21 to equal 4 out of 7. All right, using your knowledge of scale factors, find the value of x. Well, 21 divided by 3 is equal to 7. So x divided by 3 has to equal 4. So what number divided by 3 is 4? That's 12. So he can invite 12 girls. All right, the ratio of games won to games lost for a baseball team is 3 of 2. So they've won 3 and they've lost 2. The team won 18 games, so they win a total of 18 games. How many games did the team lose? So first, we're going to write a ratio comparing the number of games won to the number of games lost. Well, they won 3 and they lost 2, so 3 halves. Write a proportion where x represents the number of games the team lost. Well, the team lost x games, right? That's what we're trying to find. And they won 18. So hold on a sec. Let's look at the 3 halves. This was wins versus losses. If x here is supposed to represent losses, it needs to go on the bottom of our proportion. And then if they won 18 games, 18 has to go on the top of the proportion. All right, using your knowledge of scale factors, find the value of x. Well, 3 times 6 is 18. 2 times 6 then gives us 12. So they must have lost 12 games. Okay. The ratio of games won to games lost for a soccer team is 2 to 3. So these are your wins. These are your losses. How many games will the team win if they play a total of 20 games? So, according to this ratio, they have had 5 total games so far. So when we write our proportion, we have to have total to total. And we're also wanting how many games will the team win. So out of the first ratio, we only want to use the wins. So wins out of total has to equal wins out of total. So now we're going to use our scale factors. 5 times 4 is 20. 2 times 4 is 8. So we expect them to win 8 games out of 20. All right, the ratio of faculty members to students at a college is 1 to 8. So faculty to students. If there are a total of 480 students, how many faculty members are there? So since we're wanting to know how many faculty members, that's going to be our x. So we have 1 faculty member for every 8 students. That should equal x faculty members for 480 students. Well, 8 times 60 is 480. So it's 1 times 60. There should be 60 faculty members. Okay. On the next page of your Explorer, it says that you have 3/4. It wants you to write a fraction that is equal to 3/4, so I chose 6/8, and I got that by multiplying the top and the bottom by 2. So those two are equal to each other. It then says multiply the numerator of the first ratio, 3, times the denominator of the second ratio, 8. 3 times 8 is 24. Then it says multiply the denominator of the first ratio times the numerator of the second ratio. 4 times 6 is 24, so they happen to be the same. Then they also wanted us to write a fraction that is not equal to 3/4. 3/4, which is 0.75, is not equal to 2/3, which is 0.6 repeating. Okay? So it also told us to check the numerator times the denominator, by the way that's 9, and then the denominator times the numerator, by the way that's 8. So they're not the same. They want us to conclude here that if your fractions are equal to each other, or in other words, we have a proportion, that you could multiply or cross-multiply the numbers, and they should give you the same thing. So it says in a proportion, A over B equals C over D. The products AD and BC are called cross products, and in a proportion they must be equal. So we're going to use that to solve proportions from here on out. So these last problems use cross products to solve. So the way I do this is I do 3 times 10. That's 30. And I set it equal to 4 times x, 4x. Then I divide by 4 on both sides, and I'm going to get x equals 7.5. The reason we do this is for whenever our scale factor is not a nice, pretty whole number, it's so much easier just to do it this way. Alright, on number 14, 5 times 5 is 25, and it has to equal 2 times m, 2m, divide by 2. So m is going to equal 12.5. And the last one, 2 times 12 is 24. 3 times 2x is 6x. Divide by 6. X has to equal 4.